give the host control to him.
Okay, is Abhay joined?
Maybe he will join in 1 minute.
Okay, okay.
Arun, Abhay has joined. Abhay Kobadi. Give the host control to him.
I will make Abhay as a presenter.
Yes.
Yeah. Abhay, you can go ahead.
Still connecting. Just give it a few minutes. It's taking long time. Still saying connecting for my share request. You guys can hear me, right?
Yes, Abhay.
Uh, let me try re-logging. There seems to be some issue taking forever.
Yeah. Meanwhile, Arun, I can start. Let Abhay join. So I will share my screen.
Okay.
Can you make me a presenter, please?
You can share now, Mayuri.
Yeah. Let me know if my screen is visible.
Yes.
Okay. Hello all and good afternoon. Hope you have enjoyed your Diwali time. And last week we have discussed about template for our phase 1. And today we are going to discuss about the two slides from this template that will be additionally from the last year and for the new for the old teams and for the new teams to from the mostly focusing on the embedded side. And so Abhay from the embedded will explain how to what is expected out in the slide. And we can have the Q&A session afterwards. So first, this is the power flow diagram. This is the one of the example that I have shown here, and this is the power flow diagram you need to draw for your overall system, and then this architecture flow diagram for the embedded system you need to draw. So first, I will first explain about the power flow diagram, and architecture diagram will be explained by Abhay. Okay. So here in this case, this is the one of the example. So in this tractor, there is a you are taking the power from the two systems, that is from the ground wheel, and you are driving your driver transmission mechanism through the shaft to the, then it is transmitting to the transmission assembly, and then output will be the your digging wheel, it is rotating. So this is the one of the power flow. And for the other systems, if you are suppose one of the example, you are taking power from the PTO and then you are using the alternator, then your battery is charging, and then you are using this battery power to pick up your the different subsystems. So this is here the how the one of the example from the power flow, how it is transmitting from the tractor to the different subsystems. So in this way, whatever mechanism you have chosen or whatever uh, uh, power flow is from your side for related to your system, here you need to draw in the power flow diagram. This is a simple thing. And now we will go to the architecture flow diagram. So Abhay, you have joined or still you have any issues?
I joined.
Hello.
So yeah, I have joined.
Are you able to share or you can explain it from here?
Let me try now.
Yeah, please.
Are you guys able to see?
Yeah, yeah.
Okay.
Arun, we are recording the session, right? Okay.
Yes, Mayuri. Yeah.
So yeah, talking about flow charts, architectural flow charts. So whenever we design a system and then we want to write a code for it, um, before writing the code, we need to understand like how our logic will work. So once to define that logic, what tools we use are flowcharts and algorithms. So this is an example of a system where we are using a flowchart to denote our logic. So there are some subcomponents of this diagram, like these are few of the basic ones which will be used. There are few more other than that, but it's unlikely that you'll need it. So square or rectangle block is used to denote a process. A trapezoid kind of a shape is used to when there is a data entering or exiting from your system. Um, Such shape is used when you have a decision to be made, and based on these corners you can take different decisions and you can denote that. This block is used to denote if you are waiting, there's some delay, waiting on input, any kind of wait, you have to use the system, and these are the shapes we use for start and stop. So there are multiple tools how you can draw these diagrams. uh, you can use Word, you can use Visio. One simple tool we have is draw.io. It's a free tool. Anybody can open it. All you need is a Java runtime environment, and you should be able to uh, use that. So have already created one chart to explain this. So your algorithm will depend on your design, right? So what, let me first explain. Like I have just uh, one dummy design I'm considering, and based on that I can explain you how I will develop a flowchart for that, right? Um, don't go into detail of a design, just understand like from design how do I develop my logic and how do I put that in a flowchart. So let's assume that I have a robotic arm and I'm using that arm. I have a fixed position where I'm keeping this tray, uh, and let's say there's one conveyor. Once I pick up a sapling, I'm putting it here. That's taking it downwards or rearwards, and then let's say there's some dropping mechanism, and then there's some digging system which is creating hole, and then because with all this system, so it will pick a sampling, put it here, it conveyor will bring it here, drop it here, and then digging system will make sure that it that point it is delivered. With this assumption, let's go through that how will I write the diagram for it. Any question with this design? Like design is not important. How do you write a logic and denote your logic? So your designs will differ, right? And based on that, your algorithm and your flowchart will also differ. But this is just to show how you have to create that flowchart. So let's say for my picking system, for the test design, let's say I start from here, my controller boots up. What do I do first is I want to calibrate the routine to locate the tray position. Because of say, some inconsistency, my tray might shift here, right? And then instead of starting here, I'm starting here. So I'm just running at a high level. For first phase, what we are expecting is uh, a flowchart at least at a high level, so that we understand how does you plan to write a software so that uh, you can achieve the targets, right? uh, so some kind of a calibration mechanism we are running so that I locate the trace position. There could be any methods, I'm not going into details of those. Just telling like that yeah, this is something I will be doing. Based on that, then there's a decision tree. It has two branches, yes and no. If the calibration is not successful, uh, I'm planning to report it as an error so that I know that the calibration was not successful. This reporting could be anything like a glowing of a LED displaying on LCD, whatever it is, right? And based on that, I will rerun the calibration until it is successful. Once the calibration is successful, now I'm start waiting for so this is a wait state, what we talked about regarding basic shapes. So I'm waiting here, waiting for the planting to start. Calibration is done. Now let's say I enter the field and now I somehow receive a input. Once I receive that input, I'll go out of this wait state, and then I'm looking for that input if the planting is started or not. If not, then I keep on waiting there. Let's say the planting has started. I move my move the arm to the target position. Again, another decision tree. Have I reached? No. Keep moving my so that it reaches the target. Once it has reached, next operation I'm doing is closing the gripper. Again, uh, I'm checking here that is that achieved. There should be a branch here going here, and yeah, this should be, if it has not, sorry, and if it has, then I have to start a process. I have to start a process to transfer it to the conveyor. So yeah, from the diagram here, I have now picked it here, and I have gripped it. Now I'm putting it on the conveyor. So yeah, that process has started. It's transferring. Uh, Now, once the transfer is done, now there should be some synchronization mechanism so that I should know how fast I should go and pick the next sample and transfer it on the conveyor, right? So that the correct spacing is made. So now this is where the picking system and all this operation will run in a loop, right? So what I'm waiting here is a trigger from the other systems that now I have to go and pick another system. So this is a shape. Um, Oh, before that, I just forgot to explain like basic shapes. So if you come to draw.io, if you go to flowcharts, you will see a lot of basic shapes. Some of these are very software centric, like cards reading and database reading. Don't worry about those. But another one I wanted to mention is like if you have very complex flowchart and you want to create a tag, like some input is coming from another flowchart. If it is coming from the same same page, then you can use this, create a tag, name it whatever, and then I know that input to this is coming from this system, right? And there's another one, if it is coming from another diagram, then we use different shapes. So that's about that. So before going and moving the next sample, what I'm doing is I'm waiting for the trigger from another digging system that now it is ready to receive the next sample, right? So that's how I'm planning to synchronize my system. Um, Once the picking system, and let's say I get a request from another system, how that is sent will go through that, right? But until I get it, I'm waiting here. Once, as soon as I receive it, I'm going back again, moving my arm to the next target position. So target will obviously change. So I I picked this one. I dropped it here. The work of my picking system is done. Now I'm waiting for the input from the downward system so that I can go back, pick the second sample, and put it back into on my conveyor. Right. Another simple flow chart for conveyor system. The conveyor system starts. It detects that sampling has received, uh, and then I receive my target speed, like at what speed I should be running the conveyor, so that um, so maybe for better representation, this could be also input here, that I'm getting this, and then based on that target speed, I'm commanding my motor. Moving to third system, our digging system, let's say it starts, it will receive vehicle speed. I'm not, so this symbol is for anytime data is entering or exiting, right? So this is for data. So this denotes that, yeah, I'm receiving vehicle speed. There could be another system which is calculating vehicle speed, vehicle speed. There could be different mechanism. There could be separate flowchart for that. If it is coming from different flowchart, again, you can use such method, draw that flowchart and get that input here. Based on the vehicle speed, I'm calculating how much acceleration is required to maintain the correct spacing. Uh, Based on that algorithm, I will know that now, based on that delta t, I know that I should be sending the request for the picking system so that it is received within the next spacing, right? And internal to it, it will command, let's say I have a motor where which is I'm using to make a hole in the ground. I'll command that, keep doing that, keep checking vehicle speed, calculate acceleration, keep sending commands to the picking system, keep making holes, and this loop continues. Picking system is working in this loop, uh, continuously going to the target position, picking it, placing it here. That's one loop. Conveyor is running in one loop, is checking for the request target RPM for this conveyor. It's maintaining that RPM. And then digging system is also working in a loop, making the hole, sending the request for the target for this conveyor, and uh, the acceleration for this arm. So that's how I will write a flow chart for a system. Uh, yeah, let's pause for some questions. Do you have any questions?
So just to add on here, everyone will have their own design. Okay. So what Abhay showed, that was Abhay's design. Okay. So every team has a, you have to design your flow chart, and you have to present it in your milestone PPT, right? So if you have any concerns, ask today what issues. If it is first time for you, no issues. You will. It is very easy. It's not difficult for you guys. Only you have to show your thoughts in the form of flowchart. How you are going to perform the digging operation, how it will be the closed loop. That you have to put that into the flowchart. किसी को कुछ क्वेश्चंस है? सब समझ में आ गया फ्लोचार्ट?
काही कळालं नसेल तरी सांगा.
Hello, good evening, sir. So as the system has different slides for each mechanism, different like pickup, conveyor, and overall chassis. So we have to make different flowcharts for every system, and we have to write in that what proper slide differently, or we have to make a single.
You can make single, you can make multiple, but advantages of having multiple, you can manage the complex based on how much details you are adding. If you are adding in one flow chart, then your loops will be very difficult to understand. Like in this example, if you see, I could have combined all these, right? Combined all these system, and then denoting this synchronization mechanism would have been very difficult to understand, right? Where the flow is going. If you can divide it, then it will be more readable.
Okay, sir. But this this overall system's flowchart will be in one slide or different?
Yeah, it will be
So
in one slide, Atish. So one slide is for architecture. So in one slide, you need to show overall this system, and separate slides are there for the picking system, digging system. Then that is the, if you can able to see in the template. Can you show Abhay the template? Can you go to the one of the subsystem slide below one? Yeah. Picking system. So here only you need to answer on based on these questions how your design is, and from the embedded side, if you which embedded system, which type of sensor you are using, what are its specification, in that only you need to add here in the subsystem design. But overall, this is the logical diagram. You need to draw a logical diagram only in one slide for all the subsystems here in this slide.
okay, ma'am.
Yeah. Okay.
For ma'am, like this, we have to do same for the mechanical system, no?
No, mechanical system, there will be no logical diagram. If you can see above slide, you can combine, if there is whole totally one mechanical system, you can only one portion will be, a blue one will be there to show the power flow diagram will be sufficient. If your system includes embedded only, then you need to draw the logical diagram. Then other than that, if that is optional, if your system is totally mechanical, then there is no need to draw this logical diagram. Only you need to draw this power flow diagram over there.
Okay, ma'am.
Yeah. You understood all the shapes and what is its significance and how it is reflected in Abhay's flowchart, because that understanding is important for you to draw this architecture flowchart. And this is the just generic version of this flowchart that is presented today, and there is much more details to it. And after the phase one, you need to draw that. We will have one session, and you need to draw before the POC in detail the logical diagram, including all the details. So your understanding for this is very much important, and this will be very much helpful for you before finalizing your embedded systems, and before you are starting any fabrication for any part. So that's the why we have included this slide, and just uh, uh, ask any questions if you have for your better understanding, and any language will be okay. Hindi, Marathi, if you have any comfortable, Abhay and Nishant will answer. You can ping your questions in the chat also. And Abhay, can you also share that link of that tool in the chat so students can refer to create this flow chart?
Yeah, sure.
Once you create the flowchart, just don't add the image, even share your link here, because we can go through that link and we can easily zoom out and zoom in and see the flowchart is okay.
Abhay, you can ask one of the basic questions from this flowchart to the students. If let's see if anyone able to can answer that.
Okay. So this shape, when should I use this shape?
Students, you need to speak up. This is for you. The sessions are for you, and you need to draw this flowchart in your phase one.
If you remember going back to this, like this is the same shape, right? What are we using this for? Come on, guys. You can see it here, right? Speak up.
It is used for decision.
Yeah, right. So you are making a decision here. Yes.
मीटिंग लावू शकतोय काय कसं काय बरं ह्याच्यात आपली
That's correct. That this is used to make a decision. There could be different branches based on that decision. That's how that will help you to understand how the flow goes. Let's have one more. Like, what is the difference between this block and this block?
What, at least can you tell that what is the rectangular shape indicates and what's the that another shape indicates?
Its rectangular shape indicates the process, and above the shape indicates the data.
Yes, correct.
That's correct. I guess people have understood. I'll revise, like, this is data entering, exiting. This is any process happening. This is one is you're waiting on something. To use these tags like data coming and out. One good thing of draw.io, like if you just hover over it, it will tell you what that block is used for, right? So if I go over data, it does tell me that it's a data tool. If I go over decision, tells me that it's a decision. This is the another one I was talking about. If I'm getting a reference from, let's say, some another diagram, then you can use this. As I'm using the same diagram, I have used this block, which is on page reference. So on page versus off page reference. If you are merging, you can use this, like two logical flows coming to one point. You can use this. Just explore it. But mostly, I think you should be able to denote your logic with these basic shapes. Most important thing is, rather than these shapes and everything, is logic. How do you put your logic so that you are able to convey how you are going to design your system?
हेलो सर, हमारे सिस्टम में पिकअप सिस्टम और कन्वेयर सिस्टम है और डिगिंग सिस्टम हमारी मूवेबल नहीं है, तो डिगिंग सिस्टम का भी फ्लो चार्ट बनाना जरूरी है?
नहीं, these are just for explanation. Let's say, even means whatever logic you have, like whatever systems you're defining, there could be multiple systems, right? I can design a software such that the synchronization is handled by some other process, right? You can call it as a process and draw that flowchart and get the inputs. Yeah, it's not that these has to be these only, right? You just have to explain whatever code you are going to write and how define those in system and draw those logic. जैसे मैंने यहाँ पे जीपीएस का स्पीड रिसीव किया, राइट? तो मैं और एक सब सिस्टम बोल सकता हूँ कि नहीं, क्या ये सब सिस्टम रहेगा जो स्पीड कैलकुलेट करेगा। तो मैं कैसे स्पीड कैलकुलेट करूंगा, उसका क्या फ्लो चार्ट रहेगा, वो एक और एक फ्लो चार्ट हो सकता है। तो हाई लेवल पे, फॉर फेज 1 हाई लेवल पे आपको ये ऐसा फ्लो चार्ट बनाना है जो एक्सप्लेन करेगा। तो ऐसे लिमिट मत कीजिए कि यही सब सिस्टम है तो इसी में इसी को टेम्पलेट को फॉलो करना है। इसका मेन इंटेंशन क्या है, आपका डिजाइन हमको समझना चाहिए, राइट? कि आप क्या बनाने वाले हो।
और ऐसा नहीं होना चाहिए कि अभी अभी के डिजाइन में कैलिब्रेशन पॉइंट था, तो वो उसका एक्चुअल कोड में भी कैलिब्रेशन होना ही चाहिए। अगर बस आप डिजाइन में डाल रहे हो कैलिब्रेशन और एक्चुअल फाइनल कोड में आप बस एज इट इज नॉर्मली डिजाइन करना ऐसे कर रहे हो और कैलिब्रेशन है ही नहीं, तो वो लॉजिक नहीं बनता। आप ये क्यों बना रहे हो कि आपका जो कोड बनेगा इस हिसाब से बनेगा आगे जाके। So make sure that it's not only for theoretical purpose आप presentation में डालना इसलिए डाल रहे हो, not like that. You have to build this flowchart considering to your upcoming code. Okay, आप वहाँ पे कैसे मॉडल स्ट्रक्चर कैसे बनाना चाहते हो, क्या चीजें होंगे वहाँ पे, तो वो सारी चीजें आपको टेक केयर करने पड़ेंगे इसमें।
Okay, question in flowchart, we need to include our innovation part only or system flow only. Innovative part भी जो है, you are going to write a software for that, right? And that will add a input to that innovative part will be part of some of the system like pickup or digging or conveyor, or it could be a separate subsystem in itself, right? But that inputs you have to show in flowchart, so that
If
फॉर एग्जाम्पल अभी किसी का कुछ तो मैपिंग वाला पार्ट है, तो मैपिंग के लिए क्या चाहिए, जीपीएस है, तो जीपीएस का मॉडल आएगा वहाँ पे और उसको आप उस हिसाब से यहाँ पे आपको इंटरफेस करना पड़ेगा फ्लो चार्ट में।
if you're taking any input from the same controller or battery, then you can add it in the flowchart. If your innovation system is other than that anything, then it is not included. It is a part of the embedded, then you can add it here. Any more questions, Tim? You can drop in the chat, ask as many as questions, because we will not have time ahead much. For the so Deepak, let's talk about first flowchart here, and for the FME we will have another session in the next week.
so I'll add few more things with this tool. So it's free, very intuitive. Like you saw a couple of changes me making it. It's very easy to edit, unlike Word or Visio. Once you have created it, you can save that as a XML. So you can make incremental update. Just go here, say save as, and then it does save it as XML. So you'll have a local copy for you. And anytime you want to export to external work, you can export it as a JPEG or HTML, and share that. There's a publish feature as well. If you create that, it creates a link. I have tried to use it today, but I'm not pretty sure that how. So let me copy this and put it in chat. I don't know, will it work? But yeah, that's another way. Maybe if it did work, then that's one way. You can share your design.
Yeah, I'm able to see it. Might be it has an access also.
And this is the URL for the tool itself. Earlier it used to be, oh, looks like it's working. So yeah, you can just share that link with your presentation and we'll able to have a look. There's a question from mechanical power flow. Mayuri, do you want to take that?
Yes, so what is the if I'm taking power from only battery, then we need to mechanical power flow or not? It is not a mechanical power flow diagram. It is a just power flow diagram. How you are implement power flow diagram, it is flowing. If it is from the battery side, how it is going to do that, or if it is from other PTO or any side, then how it is. The power flow diagram is just not for mechanical. It is for the all. Can you go to the slide over here in the power flow diagram, please, Anna? Abhay? So if you can see here, the both systems are used, one from the battery and one from the alternator. So ground wheel. So some are using it for the digging system. They are using it from the ground wheel power, and then some of the using from the battery. So which system and how the power flow is happening in your system, you need to show over there. This is power flow diagram, just not for the mechanical only. It is that it is for the all systems. And if another that flowchart, logical flowchart, it is only for the embedded. Is it clear?
Hello, ma'am.
Yes.
Ma'am, I'm Bhavesh from Team SGS. Ma'am,
Uh-huh.
my doubt is regarding TIFAN template.
Okay.
Ma'am, regarding the slide includes that bending calculation and FA analysis. I feel the data might too detailed for a single slide. Would it be
Yeah, you can use
okay if
another
we
side.
split it?
Yes, you can
Okay.
use another slide for that. Yeah, sure.
Okay, means
Only
we
for the
add some more slides.
one more only.
Okay, okay, okay.
Yeah, yeah. Only for the FEA, not for other slides.
Yes, ma'am.
Yeah.
Yes, ma'am.
So whatever the template we have attached to the SAE page, that was for your reference. We have modified some of the things, and we will be uploading the latest one in the next week. And also we will take, you can go through all the slides. We will have the FMA and FEA session next week. 2 sessions will be there. So you need to submit the PPT on the 15th of November. So you can able to get some time. Also, we will have one tech Q&A session. So if you have any other than these 2 sessions, if you have any questions, you can go through this logical diagram, power flow diagram, any DFMA, other sessions. You can go all through the sessions, and if you have any questions, we can before the our final round we can discuss in one session on the tech Q&A, and bring all the questions to that session. So our all team members from the tech team will be there, and I think that will be sufficient from our side. And if you have any questions, we can go ahead, or if not, then communication team, if you have any thing from your side, you can.
Yeah. So I think thank you all for responding to the survey which has been floated for the first phase design round. I hope everyone has received the link and everyone is able to access that. So those who have not responded yet, please do respond by tomorrow first half, so that we can plan on to the further actions for the event. And the template is already been uploaded onto the website, so you can refer that template. Also, like regarding the those who are not able to attend the event, those who are from Maharashtra and Madhya Pradesh, so they have to give the reason and upload a copy of their exam over there, of any reason over there, so that we can refer to that and we can think of some other solution or some other way to take the round for them. So yeah, please, that's all I wanted to say. Any queries onto that form or anything from the students? Okay. Yeah, that's all, Mayuri. Maybe then
Yeah,
we can close.
yeah, yeah. Thank you, Sneha. Thank you all for the joining, and thank you Abhay and for the presenting detailed session for the flowchart. Thank you Nishant for supporting, and if no questions, we can close it here and see you in the next week. Thank you.
Thank you. Good day.
Thank you all.
Thank you.
Thank you all.
Usually, I will answer. Third thing, certificate of participants, sir.